Welcome. All right, so ladies and gentlemen, if we wanted to go ahead and evaluate our 6 trigonometric functions for negative 13 pi over 3, we know we're going to be going in the negative direction, which will be clockwise. But if you guys really want to graph this, then, I guess you can do that. You can break it up into thirds and say negative 1 pi over 3, negative 2 pi, negative 3 pi, 4 pi, 5 pi, 6 pi, right? And then going all the way around would be negative 12 pi, and then that would be negative 13 pi. And that's fine. If you want to create a triangle and go and graph it, that's perfectly fine. But also what I like to go and do is just go ahead and determine the coterminal angles. Because if you can determine coterminal angles, at least the smallest negative coterminal angle, since this is a negative angle, it's going to be the exact same value. So what I'm going to do is I'm just going to add periods of revolution, which would be 6 pi over 3. So if I add 6 pi over 3, I'm still going to have an angle that'll have negative 7 pi over 3. So I can add 6 pi over 3 again to get a negative angle. And therefore, I can determine that the smallest coterminal angle is going to be a negative pi over 3. So therefore, that's going to be angled down here, which is negative pi over 3, which you guys can see is a direct reflection here of my angle positive pi over 3. So therefore, I have the coordinate point 1/2 comma square root of 3 over 2. And if I wanted to be able to determine, well, since we're in the fourth quadrant, we now know that the y-coordinate is going to be negative. So when I'm evaluating my sine, cosine, and tangent, now it makes it very simple because now I know the points on the unit circle. So I can just evaluate the x and y coordinates for my trigonometric functions. So sine represents the y-coordinate for the point where it crosses. So that'd be negative 3 over 2. Cosine is going to be positive 1/2. And tangent is going to be negative square root of 3 over 2 divided by 1/2. Now you can multiply by the reciprocal of 2 over 1 on top and bottom. You can also understand that 2 over 1 the 2's are going to divide into 1, and I'm just going to be left with a negative square root of 3. For the cosecant, that's going to be 1 over y, so that's going to be 1 over negative square root of 3 over 2. And again, when you multiply by the reciprocal on top and bottom, that's going to multiply to 1, and you're just left with a negative square root of 3 over 2. Right? If you multiply, I guess I might as well just show my work. I don't need more students getting confused by what I'm trying to say. So negative square root of 3 over 2 times negative square root of 3 over 2. That multiplies into 1. So I'm just left with the negative square root of 3 over 2. For 1 over x, that's 1 over 1/2. Again, multiply by the reciprocal. And therefore, you're just left with 2. And then for cotangent, I'll actually break out cotangent because I have a little bit more work. So that's going to be the x 1/2 over negative square root of 3 over 2. And just like I did in these cases, and what I could have done over here, but I just tried to simplify it a little bit further, multiply by the reciprocal, which would be a negative 2 over square root of 3 on the top and on the bottom. Okay, so when you do that, that multiplies to 1, because any fraction multiplied by its reciprocal, or any number multiplied by its reciprocal, is going to multiply to 1. Now I'm left with, now here, the 2's divide into 1. So I'm left with a negative 1 over the square root of 3. Well, now I can rationalize my denominator by multiplying by the square root of 3 on the top and bottom. And I'm left with a negative square root of 3 over 3. And that's going to be your final value for the cotangent of your angle, negative 13 pi over 3. Thanks.